All right, so quiz 2 from 2023. First problem, label each molecule below as either an electrophile or a nucleophile, and then circle the atom in each molecule that is either electron poor or electron rich. So a lot of folks did some interesting things here, kind of maybe overthought it. So a molecule usually has a site, an atom that's electrophilic or nucleophilic. And so what you have in these cases essentially is, this is HF, this is a really strong acid. So you got to, it's a reactive acid. You got to recognize that it's an electrophile, right? And the part that's electrophilic is the H part. What I mean by this is that it's not going to act like a nucleophile. Even though there's lone pairs on this fluorine, when it reacts to something, it's going to act like an electrophile. So the H is the electrophile. Iron bond to 3 chlorines. Chlorine wants 1 bond. So even though these are electron rich, they're not actually the part that's going to react. That's going to be the iron, that's the electrophile. And then this one was a tough one, but I want people to think a little bit deeper about this. This is definitely going to be a nucleophile, but which part was actually nucleophilic? A lot of folks said the pi bonds, which was fine, didn't get full points, but it's actually the lone pair on the phosphorus is the best nucleophile, right? Because the pi bonds, if you use those and you have the pi bond react, it actually breaks aromaticity. But if you have the lone pair react, it doesn't break aromaticity because that lone pair is in an sp2 hybridized orbital. For this one, using arrows, draw 3 different resonance structures, and then star the atoms where an electrophile would add in an electrophilic aromatic substitution. So what that means is essentially you need to draw resonance structures, but then I also wanted you to think about how this is going to affect reactivity. I guess that's the way I was thinking about this. So you draw some resonance forms here, and you get a negative charge there. Right, another resonance form, breaks the pi bond, goes to nitrogen. Another resonance form, right? I only asked for 3. I think I drew 1, 2, 3, 4, 5. You only needed 3. And then all the carbons that end up with a lone pair in the negative charge would be considered electron rich, and those are places where an electrophile in theory could add. So a couple good questions. I will always be sure to tell you how many resonance structures to draw, so you don't need to do all of these. I drew more than you needed. I asked for 3 and I drew 5 just for completeness, so people could see that. So I will always tell you. And another question is how many arrows to use. So you gotta kind of think about. There's no rules, right? There's no like hard rules like, oh, I draw 2 arrows always here or 1 arrow. What I do want to see is electrons from outside the ring going into the ring. I don't want to see, right, just an aromatic ring go around. That will not earn you full points. So I want to see electrons, right? If you have lone pairs outside the ring and they're in a p orbital, those are the ones I would probably think about using, right? We've seen lots and lots of examples of these kind of things. But there's no like hard and fast rule like 3 arrows is right, or 2 arrows is right, or 1, right? Depends on the situation, right? So think about the rules, right? For resonance structures, electrons in p orbitals, right? You want to start arrows at electron density, lone pairs and pi bonds, right? Don't start arrows at H's. Don't break sigma bonds, right? Don't move the position of atoms, right? Those resonance rules, remember those things and try to like slow down, number your atoms, right? Those are the kind of things that will really help you with these. Look at the examples we've done, right? There's pretty much all the examples you could possibly think of are right there. So for this one, label the molecules below as acid or base. Draw the mechanism arrows for the acid-base reaction. Draw the products of the reaction, and then which side is favored. Start materials of product. So depending on how you answered this, there's lots of different ways to earn points for this, right? So, right, if you called this an acid and this a base, you could still earn those points, right? As long as you're consistent with your arrows, then, right? So where do arrows start at? The arrows always start at bases, right? Their bases are electron rich. So I've tried to not double penalize folks on how I went through this, but the best answer, this is the base and this is the acid. Somebody might say, how do you know that? There's an NH, there's an OH. Well, which one's a more polar bond? NH or OH? Well, oxygen's more electronegative. This is a more polar bond. That also makes me think it's more likely to be an acid. But why this nitrogen and not this nitrogen? Well, this nitrogen has a lone pair, but this nitrogen lone pair is in a p orbital system for aromaticity. This lone pair is in an sp2 hybridized orbital. So it's more reactive because it's not doing any resonance, and it's not doing resonance in an aromatic ring either. So this is the best base. This is the most polar bond to hydrogen. So they deprotonate. Now, and then of course make sure you have your arrows right, and then draw the two products. Now, here, you know, I asked which side is favored. If you said star materials because there's no charges, you earn the points. If you said products because this one can do resonance, you also earn the points. I wasn't looking for necessarily the right answer. I was looking for like the explanation more than anything else. Like, right? Can you look at these two things and say, well, these side has charges, right? So maybe it's the star materials favored. Well, but this one can do resonance, so maybe this is favored, right? It wasn't about the right answer. It was about the explanation there for those things.